Interactivity is vital to data discovery. Thankfully, happily, there are several innovative means to gain insights faster. Among them, intuitive ways to filter, select, navigate, and scale. I'm Ann Milley, your host for today's event, and I'm super excited to explore today's topic, both visually and verbally, with our own visualization luminary, Zan Gregg. Welcome, Zan.
Thanks, Ann. This is a topic I've been working on for many years, and so I'm happy to present it all in one place and have some discussion about it.
We are looking forward to it. In today's talk, Zan will show and categorize a dozen methods of interactively exploring data to speed time to discovery, even with large and varied data. If you have questions, please submit them in the Q&A and we'll take them at the end. We hope you'll share what you learn on social media using hashtag #StatSpeaking. Zan Gregg is a distinguished engineering fellow at JMP, where he focuses on data visualization in JMP development. He created JMP's Graph Builder for drag and drop graphing and data exploration. Zan continues to spearhead many user productivity initiatives, including header graphs, interactive data cleaning, action recording, and more. In 2006, Zan won first place in a worldwide data visualization competition and has been active in the online data viz community ever since. He invented the packed bar chart type for high cardinality data, and he makes all kinds of graphs that he shares in social media and on his personal blog, Raw Data Studies. He also blogs regularly on the JMP community. Let's hear from Zan.
Hello, everyone. I'm Zan Gregg in JMP Development, here to talk about interactions in data visualization. Interactivity is quite common these days and not controversial at all. So what is there to talk about? Well, because it's so common, there's quite a variety of interactions out there. And it is good to keep in mind all the ways that things are interactive. It's not just a true-false thing, you're either interactive or you're not. It's how interactive is a graph and in what ways is it interactive. So we're going to try to enumerate some of those ways or methods. And just for context, I'm going to do a couple definitions before we get started. Data visualization, hopefully not controversial. It's just a graphical representation of data. And a interaction, though, might be a little trickier because things can be interactive at different timescales. But for this discussion, I want to focus on interactivity that's immediate. Certainly, you could have an interactive experience where you're writing code and running it and seeing the results, and then writing more code and running that and seeing the results. That's interactive in a sense, and nothing wrong with that. But I'm going to focus here on things that are more immediately interactive with a point-and-click style interface. And a little context here for reference. I'm going to start with my references, just because I'm going to use some of the terminology, especially from this first book by Ward, and called Interactive Data Visualization. And they outline several operations, they call them, and I'm going to relate the particular interaction methods to those operations where I can. There's also a paper by Hare and Snyderman that presents a different taxonomy that's a little broader because it encapsulates some of the data prep work and before and the sharing work afterwards. But I thought that might be of interest. And finally, I covered this in a short panel discussion a few years ago at the Joint Statistical Meeting. And so that blog post is still available for comparison. But for now, I'm going to use a different data set than I use there, and I'm going to be able to go in a little deeper into some of these methods. So the data set I'm going to use is from the Bureau of Labor Statistics. It's called the American Time Use Survey. And this survey has been going on for 20 years, and they basically interview a person and ask them what they did the previous day, really, to 24 hours, minute by minute, what they were doing. and not too many categories, but they do categorize things, and so it's a little summarized there. So lots of data, lots of variety of data, and so I think it will serve a lot of purposes for illustrating some interactivity. So let's get right into it. Switch over to JMP. And one reason I like this data set for illustrating interactivity is because it's big. And I think it's important to keep that in mind for interactivity to also support big data sets. It's easy to be interactive for small data sets. But this data set has almost 250,000 observations, interviews over 20 years. And it's got many variables here. I've got about 100 variables that I've pulled from some of the various files. If you download the data, it doesn't come in just one file, but I've sort of encapsulated things here just to make things simpler. So here's our data set, one row per interview, and here's our list of columns. There's quite a variety, but there's some are demographic based, not related to time use, and there are some labor based, since this is the Bureau of Labor Statistics, about your job, and but most of them are time based, usually measured in minutes. So minutes that you spent on the previous day doing that activity. And so here's the main categories of activities, and they broke out some of these categories. So here's the ones for leisure, and I've captured a few more demographic things as well, including some geographic things, so we can look at a map as well. So let's get right into it, and with our first interaction, and that's what I called in my blog post graph building, and I think it fits into the Word book operations. I'm going to say, as they have an operation called reconfiguring, even though at this point we're configuring, we're just creating the graph. So we're assigning variables to different roles in the graph. So we can take a variable like age, put in the Y, we see some graph. In this case, JMP tries to always create some graph no matter what you throw at it. And so with one variable and lots of observations, it gives us a histogram. We can put it on the X. And so this is interactive as we're moving things around. It's updating the graph. So I'll just drop it there. And we can already see a little bit about the data, about the distribution of ages in the survey. And I'm going to bring in another variable. Let's bring in weekly hours. So that's the hours that you work in a typical week. So this is not about the day before. This is just a typical week. And it's not unexpected. We see it ramp up as people enter the workforce and level out around 40 and then taper off. So this is the average trend line for all of these 250,000 interviews. Normally, JMP would show you the scatter plot point data, but for 250,000, it defaults to off, but we can still turn it on. Obviously, we can't appreciate the 250,000 dots here, but we can at least see the range and some characteristics, how their ages and weekly hours are both integers, so we get things on a grid and overstriking each other. We can also see how the ages behave, where they top code the ages at 85 now, but they used to top code it at 80. And for whatever reason, they kept that by convention. Even after they've moved it to 85, the ages between 81 and 84 also get still coded as 80. So you just, you can learn these things just by interacting and reconfiguring the graph, as they say, adding points here, looking at the smoother. We can also hover, another interaction, sort of see what some of these points are. I've marked a couple of these fields, age and sex, for labeling, and the other two are coming in because, or the weekly hours anyway, is coming in because it's on the graph. And so that's the hover details, and that's another interaction that's related to increasing your level of detail. And we'll have more on that later. But for something like this, for a view like this, you might use that to hover over some outliers like we just did and try to identify whether they're true outliers or some kind of miscoded variable. But in this case, with 250,000, we're not going to go through one by one and do that. And fortunately, with this data is relatively clean. So let's continue reconfiguring. We can switch our views here. We can go to a line chart and see the mean per age as a line. So the mean is here, the summary statistic. We can change that, say median, and now, not surprisingly, 40. We can see the predominance of 40 as the weekly hours. And how that drops off, we can switch to area chart or bar chart, go back to mean. Lots of options here. So these are all different ways of configuring the data and possibly getting different insights in each one. Let's configure some more by removing this y variable. And so now we're just looking at count. So this is very similar to the histogram, except we're not looking at bins of 5 years each. So now the 80 and 85 are more prominently out of range. And we can see a little clearer this dip at the younger ages. Don't know what that's about. But we can, as far as thinking about that, moving into the working population and the weekly hours, how it relates to the younger ages, there is a field called student that indicates whether someone is a student or not. And so we could get a better sense of how that's affecting the weekly hours by just looking at the counts for each type of student. And not surprisingly, full-time student is common with the young ages. And so that was probably driving that weekly hours figure. We can also, we're looking at it now as a grouping variable, sort of paneling, and we can also use it as an overlay variable. Same kind of data, same kind of separation of data, but now they're interleaved. So the same bars as before, that is, but just interleaved now and colored by the student value. We can also reconfigure that to be stacked instead of side by side within each age. And we can change the statistic again to be percent of factor to give us a 100% bar chart kind of look, to give us a proportion of the population in each category. So that might explain the weekly hours at the front. But at the other end, we might notice we're not even getting anything here. And I thought maybe I'd had an error combining the data sets. But when I went and looked at the survey, I realized they don't even ask the question about whether if you're a student or not, if you're age 50 or more. So that's why that only goes to 49. But there are other variables. There's the labor force status, and that could be just as telling. So let's move that in as the overlay instead. And so that's, we can see the employment ramp up at the young ages and taper off at the older ages. So that's going along with that expectation with the weekly hours. Okay, so that's a good bit of configuring. Let's move on to some more interactions. I'm going to start over. And next interaction is related to the children, and there's a lot of fields about children and childcare, which is a kind of labor that they wanted to capture statistics about. So we got number of children. This is when your first child woke up, when your last child went to bed. And also there's one for age of the youngest child. So I want to put that on the X. We see that histogram again. And let's look at, I want to look at bedtime. So when the last child to go to bed, I think is what it is. Yeah. The last child less than 13 anyway. So it's a little bit of a mismatch here, 13 and 18, which we'll address in a minute. We get a bit of an odd pattern here with the bedtime tapering off. And we can, but that's partly because of the 13-18 mismatch. I'm surprised there's any data here at all, but we can click on the points. And once again, we've got too many points to really see much of, but we can see some of it, and we can see indeed there isn't much data up here. And it looks like a few of these low values are pulling things down. Let me turn on the jitter so we can get a better sense of how much data is here versus in this extra region. And we notice there's a lot of bedtimes that are in the early morning hours. So that is going to be throwing off the mean calculation. And that's indeed what's pulling this down, I think. Some of these older kids are actually going to bed after midnight. So that's going to be a problem if we're going to try to understand that relationship. So let's interact a little more. And one way that I mentioned I wasn't going to cover data cleaning, manipulation kind of thing. So I'm just going to mention that I did that already, and I made a adjusted bedtime, which moves the after midnight times over to adding 24 hours to those, so they're properly seen as beyond midnight, and so that addresses that issue. And now let's bring up our data filter. And so this is a common interaction across many data visualization tools. I'm going to first filter on that X variable, age less than 18, or the age of the youngest child less than 18. And we don't really care about the ones 13 or older. So we filtered that out completely. Our line is still there. I think the points have done their job. We can turn those off for now. And we're not seeing a lot of pattern here. There's still an issue about the fact this is the last child, this is the youngest child. They may not be the same child. So one idea is we've got a field called number of children, and we can look at just the families that have one child, which is still a lot. And so that's maybe a little bit more of a slope now. We should be looking at the time that one child went to bed. And since we're not concerned too much about the raw data right now, we're just thinking about the trend line, we can zoom in on that. So one way to do that is just to grab the axis and pull in like that. We can also grab the axis and pan or stretch. So that's another interaction there. So now we can, there looks like there is a trend with moving an hour over that age range. But there is some odd shape here. It's weird that it sort of bucks the trend going from 4 to 6. And I'm not sure what that is, but I thought it might have something to do with school starting. And one way I thought to get a sense of that is to look at day of the week, because we do know the day that the survey was conducted and the day of the week that it was conducted about. So let's drag that in, reconfigure our graph a little bit. We can use it as a grouping variable in the X dimension. And we can already see some difference in Friday and Saturday. I think we can see, but it might be easier if we just overlaid them. So now each of the curves is overlaid, one curve per day of the week. And indeed, this is Friday and Saturday. So here's another interaction, selection linking, selecting in one area and having it highlight in another area. So they're all connected. And we can adjust that stiffness of the slider. That's a statistical tuning kind of interaction. And you can sort of see that, there's some level that the school nights are more affected than the non-school nights, put it that way. I'm sure that once you're going to schools, there's some carryover effect for your usual bedtime anyway. But I'm going to take these other variables just to show another interaction. We can change the color of those. So if we were going to, present this, we don't really care which of these days is which. They're all sort of the same group, but we just want the color on the ones that we think are interesting. And that's the visual encoding customization for color in this case. And as you can see, when I clicked on that, there's a lot of other options as well, style and width and so on. So those are all sort of visual encoding channels we can leverage there. Okay, let's move on to some more. I'm just going to start fresh and with a new graph builder window. And in this case, I'm going to start with a map. We've got these geographic fields at the bottom. I'm going to start with, since we're so US focused, let's switch to something international. We do have a field for what country was your father born. I'm going to put that into the center here, and which is the same as putting it into this map shape role. And Graph Builder figures out that looks like country names, so we'll make a world map. And we can color by one of these time use variables like time spent alone. Color by that. And we got a few countries missing. A lot of countries not missing. I'm surprised, but we can turn on this missing shapes field to fill in those other countries, or at least get their outlines. And we could zoom in on that like we had before. So this is a little different from our Cartesian zooming, because we're not just zooming in one dimension. We're zooming in two dimensions at the same time, because we have a geographic projection. And as we zoom in further, the projection changes to one of equal area. You can't really do equal area well for the whole world, but once you get into a more regional level, you can do equal area. And so we have that adjustment, which is different at different latitudes. So that's the idea there. Another interaction we can do is the color scale itself. This is, by default, is showing a more statistical color scale, which is emphasizing the deviation from the middle, where the middle is gray, and the deviation is either blue on the low end or red on the high end in this case. And we can change that, of course. If we want to do something more sequential, that's just focused on the low to the high bound, we can do that. And see the effect there. And we could even adjust more complicated parts of how the gradient mapping happens, by whether it's linear or log or quantile or whatever, give it specific cut points and so on. So that's a little less interactive because I have to go through a dialogue, but I wanted to show it because it is in the realm of near immediate feedback on interactive visualization. And so that's another way of changing the visual encoding. And so we can scroll around on the x-axis as well. Okay, so that's a little bit on the maps there. Geographic scaling, that's a little different nuance than the others. So for the next few interaction techniques, I'm just going to show some graphs that I've already made. And the first one is going to be about selection linking. And in this case, I've got, to show this, I've got several graphs and a table in one view. Let me make it big. So this is a histogram of age distribution. This is a bar chart showing the average reading minutes per highest education level, and the scatter plot of weekly hours versus weekly earnings, and the full table itself, all 250,000 rows. I'm going to close up this panel just to focus more on the data cells. And so the idea with selection linking is when we make a selection, it shows up everywhere. So we'll select, say, bachelor's degree, select that. We've selected one bar, but it selected all the rows that were associated with a bachelor's degree, which is about 50,000. And in the histogram, it highlights that the distribution of those values with a little darker histogram. And it may be a little hard to see, but in the scatter plot, those dots are a little darker. And in the table, those rows are also highlighted. So they're all linked together. And we can see how, in this case, how the distribution is different for different kinds of degrees. Now that's going from the bar chart to the other charts. There are some challenges with this kind of linking, and one of them is when you've got a partial selection. So in this case, if I select a bar in the histogram, say the 70 to 75-year-olds, you can see that there are some of those represented in all of these education levels. And it's JMP has different ways of showing partial selections. The way I've got turned on right now is to show a little pie chart over each bar indicating the amount of observations in that bar that are selected. It's a little more easier to see if I select a bunch of bars here. You can start to see how those might be a little different. So that's partial selection as part of the link selection, one of the challenges of link selection. The other challenge, well, I guess the challenge with all the things that I've talked about is the quantity of data, just 250,000 rows, doing all that instantaneously. But that's what the software, that's what it does the hard work for us. So let me close that up and go to a related issue called selection filter, another kind of interaction. In this case, I got a similar view with these three graphs, but I've tagged this graph as a filter. So it's going to act as a filter for the other graphs. And you get this little icon here to indicate that. Before I do that, I did want to point out another interaction that I haven't covered yet, and that's ordering. And this, we can think about the order of these education levels. I've ordered them by hand to be approximately in a reasonable order. But you can see that order almost corresponds to the average minute spent reading, but it's not quite. So if we did want it to match the reading order, we can change that. We can right click and say order by reading level, ascending from the origin. And so now some colleges after associate degree in that orientation. So that's ordering, another interaction. And so now let's get into the filtering. So I can click on a bar, and now the other graphs are completely updated to filter out the rows that don't match this bar. And I could still do a range to get a few bars selected and see how they affect the other graphs. In particular, for the scatter plot, it's a little easier to see since we don't have to deal with the distinguishing the faded dots and so on. So that's selection filtering, another kind of filtering in addition to the filtering that we saw where we added a left-hand panel within the graph window. And we haven't talked about grand tours yet, but there's a concept in data visualization interaction called a grand tour, where you basically have many variables and you want to see them all basically, but you can only see a couple at a time. And so you take a tour, and this is 3 at a time. So we've got a 3D scatter plot here. And in addition to seeing, a choice of variables, we can also choose the rotation angle to maybe see some different some features. And we can just loop through them. We can pick particular ones to look at, or we can loop through the ones that we've loaded up. And so that's the idea of touring through the data, looking for things that might stand out, be particularly odd. Like this, obviously we got some strong relationship going on here. Time, not surprising, time with family members is sort of a superset of time with children. So that's the idea of the grand tour, a little taste of that. Another aspect of that is in this model profiler, which is not looking at the raw data, but it's doing a tour of a model that's high dimensional. So in this case, I've ran this neural network model for 2 response variables, time spent alone and time with family members, and 4 different indicator factors: age, weekly hours, partner weekly hours, and number of people in the household. And so we can't really look at all the dimensions at once, as one big surface, because we've got, each one is, we've got 2 5-dimensional surfaces, 4 x's and 1 y. But we can look at these 2-dimensional profiles, which is also a technique for a grand tour kind of view, where you're just looking at lots of 2D views. And the interactivity is being able to focus on, which, basically, at which point do you look at that particular plane of the slice of the data. So here's default view is indicated by these red numbers and the dotted red lines, but we can move those and see how the surface changes. For instance, when we've got, this is weekly hours worked for the person being interviewed. When their hours are low, their time spent alone goes up as their partner hours goes up, which makes sense. And when their weekly hours is higher, their time spent alone doesn't really matter, isn't so much affected by their partner weekly hours. So in this case, the shape of the line of the fitted curve is different depending on at what point you're at. So there is, which indicates there is some kind of interaction going on. It's not just each one independently making things higher or lower. Similarly, number of people in the household, there's some effect with age. I've noticed when you've got more like 4 people, then there's some kind of peak around 30, and for time with family members, and there's a flat area up to 30 for time spent alone, which doesn't happen so much with a smaller family. So this is a little bit of a way of touring a high-dimensional surface with a sequence of 2-dimensional profiles. And the next example is showing drill down. So I've got a map that I've set up to color by a variable that I thought was interesting, relaxing thinking. This is one of their leisure categories. And it's sort of odd that they're in the same category, but it's hard to imagine exactly what they had in mind for relaxing and thinking, but I'm sure there's a lot that's covered there. Whatever it is, Mississippi is certainly the winner in that category. And what I've set up here, though, is the hover label. I've added a graph to it in the specification. And so we can sort of see the graph is showing a line chart of a little thumbnail of a line chart showing how that amount of relaxing or thinking changed over time. And so we can see it looks like, I thought maybe that might be some kind of fluke data point or something, but it looks like it's been fairly high all the time. I mean, certainly not like, is it Colorado that's showing a, relatively low level. And there's some other states like West Virginia that do have a little peak, some variation. So that's a kind of hover detail. And if I click on this, I can open up the window, and now that's more of a drill down kind of thing, where we're starting with a graph that's showing the entire country, and we're drilled down to a graph that's just showing that state, but showing it a little more detail over time, not just a single average color. So that's the idea there. We can actually get rid of that filter and look at the do a little more configuring here. So this is the average over all the states. So we can bring state in as a grouping variable. And yeah, I guess that's Mississippi there, and maybe that's West Virginia. So those are the ones with the high points. Of course, this is not a particularly good view. We can put it in the wrap roll. It's a little better. I need to maximize it so we get more space. And so now we can see all the graphs at once, now that we've identified that. But the order is maybe not so useful. Well, depending on your task, if you're looking things up by name, alphabetical is fine. If you're looking for like a geographic pattern, then you might want to order them differently. I created this derived variable grid order that's computed by latitude and longitude. So it gives us a rough approximation of geographic proximity. So all the states with the highest latitudes are at the top, at least, and all the way down to Hawaii and Florida on the bottom. So not terrible, but now we can look for any kind of geographic patterns. Maybe change it to area chart to see to get to get the axis down to 0 so we can see the amount. I'm going to switch the X though to year. It was looking at doing it by day, and so that was quite noisy. But if we look at it by year, we can see a little better any kind of trends that are going on, and states like Mississippi are going to be generally more filled in since we're using area now. So switch to that. We can also switch some variables out since we're sort of in the spirit of the grand tour. We can look at, say, actually one I noticed that was a little bit surprising to me was volunteer activities. Or not surprising, maybe, but it did. There was a standout anyway with Utah here standing out. So this is a little bit like a grand tour. I can formalize it a little more by using something called a column switcher. I'm going to click done first to close that up. Open up a column switcher, switch out volunteer activities, and maybe look at all of these leisure activities and some others. Okay, I'll get it in there, and so now we can switch between them and get a sense of how they compare. So another way of doing a grand tour, looking for each kind of variable, looking for different kind of patterns over time by state. So lots of detail here, lots of variables, lots of detail. That's the drill down and beyond, but that's how we start, get the interaction with drill down, and allows us to go further and look into more things. Okay, so let's try to get back to our categories of interactions. The values on the left are the operations from the Ward book, and on the right I've got some of the more specific interactions that I showed, and so I've tried to categorize them a little bit. The reconfiguring, I sort of expanded to be configuring and reconfiguring, so it's the chart creation, and so changing variables, changing chart types, changing ordering. Filtering is common, but I did want to show the two different implementations here, one with a dedicated filter that's attached to the graph, and another with a more general purpose filter that's where one graph itself acts as a filter to other graphs. So that's the local versus selection filtering. Selection and connection were two separate operations in the book, and I've shown them together. So I might be missing some nuance there, but shown together as linked row selection. So that's a core part of JMP. Navigation is the axis, panning, zooming, stretching, and so on. And I did show how that's a little different for geographic scales, where you've got to worry about projections. The encoding was a little bit on the legend work that I did, changing the colors and line properties and gradient properties. So that's not just changing the visual appearance of things, but also changing the meaning sometimes, particularly related to like which parts you want to emphasize, or with the gradient, whether you want to emphasize a diverging or a sequential kind of scale. So that's not just cosmetic, that is adding some meaning as well. And finally, their final category was elaboration, or the opposite of that, abstraction, and that was shown with the hover details and the drill down as a part of hover details. But there was more I showed that's not in their categorization, and one part is the statistical tuning that we did, which with the summary statistic for the bar chart and the line chart, and also the model parameters related to like the smoother stiffness, and so that I think deserves a category within the taxonomy of interactions. And finally, there's also this pre-existing interaction called Grand Tour that I wasn't sure how it fit into their categorization, but so I thought it's worth calling out. And we showed that both with the column switching and with the model profiling. So that's a grand tour of animation methods, including Grand Tour. And I tried to cover a lot, but I'm sure I left out a few things. So I'd be glad to hear more about that and or different ideas about ways of combining different things together. Um, so I think it's a rich world of animations, and it's good to keep in mind all of these ways that things can be interactive. It's not just enough to say something is interactive or not. We have to think about how it's interactive.
What a great talk, Zan. Thank you so much. So informative and so well thought through. And you're getting a lot of praise in the chat as well. So we thank our audience for that feedback. So we've got a lot of questions rolling in. Let us turn to the first one. How does brushing fit into these interaction types?
Yeah, I should have mentioned brushing because that's the term most people would probably know for what I called selection linking. Um, though there might be, though I guess the downside of brushing is uh, people know it so well that they have their own definition that might be different from someone else's definition. But yeah, there is sometimes there's a concept of a brush, like a rectangular region that you move around. And we do have that in Jump as well as a separate tool, but it's using the same mechanism of selection linking, basically highlighting all the rows and all the views.
Like
So
every other discipline, you've got different terms that need to be sometimes mapped or explained.
yeah,
So
that's one
thank
of
you.
my reasons for trying to explore this topic is understand all the terminology.
Yeah, so we've got a lot of questions. Thank you so much. Keep them coming. We'll get to as many as we can. There's one that starts with a nice compliment. This is a great tool for the data specialist, but how can this kind of interactivity be adapted to the needs of a busy manager who wants to periodically get a view of some key metrics?
Um, well, I think I mean, it is used by people that aren't doing data all the time. I mean, that's one of the advantages of the graph builder functionality I showed, where you can just open it and drag in a few variables and see how they look. And I mean, you could, I mean, I imagine if you were in that kind of role where you weren't doing the stats, you would still be able to use this that kind of tool to explore around, and then as you discover things that might be interesting, you would have someone on your team uh, check the validity statistically and do follow-up studies to confirm and things like that. But certainly it should be easy just to drop in and drag things around and try things out. Graph Builder will always try to give you some graph. You don't have to know where you're going before you get started.
And maybe just a few things to add to that, Zan, since many of our viewers are not JUMP users, that you can share some of those visualizations that you created as scripts attached to the data table. So if you emailed it to someone, a busy manager, then they could just run the script and then reproduce it. And then if they wanted to interact with it, but we also have the ability to create dashboards, and we have the ability to share these visualizations with non-JUMP users that don't need to have a license of JUMP via JUMP Live. So there are many ways you can embed some of these visualizations in slides as well. So um, we are
Well,
we are
that happened.
sensitive to
Yeah.
the collaboration needed.
Okay.
Sorry, go ahead, Zan.
I was just going to say that just was watching some of the videos of talks from our conference a couple weeks ago, and there was a statistician at Virginia Tech who was uh, working with a client about I think it's animal hospital data, and yeah, she could do her stuff and save it as a script in the jump data table, and then just email the table to her client, and the client could open it up and explore and dig a little deeper, and they could collaborate that way. So I was happy to hear that.
Yes, we are all about facilitating the collaboration because to some extent everybody needs to deal with some data these days. But we've got a lot of questions. So next one is very new to JUMP and definitely not aware of all the ways in which graphics in JUMP can be interactive. Do you have any training or reference material recommendations for how to start exploring what is available?
There is a lot. I will say that. And you might know better, but I believe one thing I often point to is there's like a live webinar every Friday, I think, or every other Friday, just getting into JUMP, you get a little demo from an expert from our education department, and then it's live, so you can ask questions and dig into it that way. So that's a good way to just to go over some of the basics to get a good footing.
Yes, and to that I would add that we have a YouTube channel where there's tons of videos that you can check out. We also have a STIPS course, Statistical Thinking for Industrial Problem Solving, and there's an exploratory data analysis module that might be of interest if you're just new to JUMP and wanting to see what else is available. But there's a lot on jump.com. There may be too much, but just to help you navigate, those are some places you could start. So great questions. Thank you guys for submitting these. Next would be, could you show how to do the linked selection and how to do the 3D grand tour? I don't know if you want to jump back up, Zan, and I should mention to our audience, for any questions we don't get to, we will write a follow-up blog post and then answer them in the limited time that we have today. So keep the questions coming. But what do you think, Zan? Do you want to do that in the blog, or do you want to tackle it now?
I'll try it. So this, I guess we're talking about this kind of 3D tour, getting that set up. So that's most of what I was showing was under some tool called Graph Builder, but this is a specialty thing called Scatterplot 3D. And so it's basically just showing me all the columns in the table, and you can just take a bunch of them and just throw them in and hit OK. And it shows you the first three, and then you can choose to change some of those, or you can use that little arrow button to slide around. The Zoom tools are covering things up a little bit for me, but anyway, hopefully that answers the question about how to get into it. Was there another part to the question?
The grand tour, but I think they're kind of interlinked.
Using those arrow keys to tour around. Yeah.
Okay, great.
There are some, speaking of grand tour, there are some tools that specialize in only doing the grand tour, and it's more like sometimes like a guided tour where it'll try to take you to the most interesting things, whereas this just lets you, I guess the problem with that is it's hard to define what's the most interesting, so this doesn't have that kind of functionality.
So you might just want to keep sharing, Zan, because a lot of these are interesting. One type of interaction when exploring the nature of an apparent cause and effect relationship is to try different axis transformations to seek a combination that results in the most linearization of the pattern. Is variable transformation interactivity available in JUMP's Graph Builder?
Yeah, certainly. Let me try to bring up I'm just trying to thinking about the
data that would lend itself to that.
Yeah, right. I could try it with this data. Obviously, like we've already mentioned, the number of points is going to make it tough to actually see all the points, but let's just put a couple in here. Turn on the data here. Yeah, so there's a few ways we might do this kind of thing. So this is, certainly we could just, probably the easiest way is just to change the axis encoding itself. We could just make it a log scale or something, or a particular power scale. And there's lots of scales for people that are interested in particular probabilities where you want to sort of assess whether the data fits that probability. But the common ones are just the log and the power scales like square root or something like that. So we could just change it. It shows you a little preview, and when you hit OK, it updates the graph with that kind of stuff as well.
Very nice.
And the other way I was thinking about is just you could make a synthetic variable. We could just say instead of that, we wanted to transform that and look at the square root of that or something, and then just drag that in instead. And so now we're looking at square root if that was interesting. So yeah.
So many options.
Yeah.
Great. Thank you, Zan.
All right.
Well, another question. How can a map, i.e. world map, be generated or imported into JUMP for data analysis? Actually, we have some maps already, right? But
yeah, I'm not sure what that's about. We do have like we showed here, we have a data which had country names, and we could create a map from that. If you have your own shapes, I mean, JMP knows countries and states and a few other partitions, but if you have something that JMP doesn't have, you can import a shapefile and save it so that JMP can use it. So there's a way to do that as well.
Okay, very good. Let's see. When monitoring real-time data in our process control systems, we struggle to quickly identify and react to small shifts or anomalies over long time spans. Are there specific visualization methods or dashboards you'd recommend to help spot and interpret these subtle trends effectively in a continuous flow system?
Mm. Well, I mean, it sounds like a control chart kind of situation. That's a whole field for monitoring processes, and it applies some statistical rules to flag things that shift or that are running, showing a trend or something when they shouldn't. So it's mainly, or it was invented for like monitoring factories where you want to check your quality control and make sure everything part sizes are the same, and then get flagged if you have like three or more out of spec in a certain time frame or something like that. So there is a statistical way of doing it with Control Chart Builder, and that's another interactive part of JMP. But otherwise, I just like to just try different views of the data. Sometimes a heat map works out well, where you're coloring by the measure, and you might notice a different shift in the color or something like that. And it's the heat map. The question mentioned a lot of data, I think. So that is a very dense way of looking at things. That helps in that regard.
Thank you. And to that, I would also add that earlier this year, we did a whole stat speaking on control charts celebrating the 100th anniversary of the Schuhart control chart this year with Bill Woodall and our own Annie Zangi. So you can find that on demand if you want to delve into that a bit more. But let's see, we've got more questions. I need to collect data from historical files in Excel and consolidate them into a viewable data analysis. Could the dashboard or script process do this?
Oh yeah, we've got we can certainly import Excel either interactively or with a script. And yeah, the data, I'm just thinking about this American time use data. It didn't come in as Excel files, but it did come in as files that had to be imported, CSV files, and also some separate code books that I had to interpret with a script. So that was all done by scripting. So if they release new data next year, I can run the same script and get a file with 270,000 rows or whatever it is. Yeah. So yeah,
And
that can be scripted and automated.
yes, and in case it's of interest too, since you were mentioning Excel specifically, we can import multiple tabs into, separate tables and consolidate them if that's a need as well.
Oh yeah, multiple sheets. Yeah.
Very good. So the next question is, could you show how to do the linked selection and filter?
The link selection. Okay, so that was so there's two things here. This is the selection linking. And well, since I got this up though, I talked about brushing, so let me show the brushing here. So this is a brush tool in particular, so I can, if you start with this guy, go into this mode. This is the mode I was talking about as far as having a rectangular area that is the brush that you move around. So that might be a slight distinction from selection linking. But yeah, as far as setting it up goes, it might take a little more time to get going, but basically I created these views and then went to is it the window menu? Yeah, so I've made this as 4 separate windows, and then I went to this combine windows command, and it lets you select which of the windows that you have open that you want to combine, and also I'll just bring it up and you can see I've only got one open now, but you can also tell it which one to filter by and which ones to include in the dashboard. So that's all I did for putting this together. So basically just created 4 separate views and then use that combine windows command.
Thank you, Zan. And while you got one of the data tables up, just to make sure the audience knows what a header graph is, that's a nice way to just quickly look at the distribution, uh, right, for each
Yeah, I can't believe
variable.
I forgot to mention that, but these, yeah, I mean, this is in the data grid view, but there's a little graph above each column to see the distribution of that column. And these are all interactive as well. So
Super
you
handy.
can,
You
yeah,
can,
you can see here that the weekends are more common um, because I guess they want to balance it out so there's equal number of weekend days versus weekdays. So they do more surveys on weekend days or for weekend days. And so we can select things and see. Basically, you get a lot of, you might call these parallel histograms that sometimes you can use to show relationships where, select the low values here and the low values are also showing up here. Not surprisingly, these are tightly related, but there might be this similar kind of thing with age and see where the other variables show up for age, how they relate to age. So you can actually get some little discoveries using these little heterographs.
super helpful. Thank you. I think we have time for one more question. What inspired you to create the packed bar chart type?
Um, well, that's yeah, it's a different topic, but I'm always happy to talk about that. And let's see if I've got anything in my recent files that's it's a chart type for something like this, these billion-dollar events that the U.S. Uh, agency NOAA puts out. Been tracking these hurricanes and other events that cause at least $1 billion in damage. And so you've got since 1980, this is only going up to 2017. But the basic idea is you've got basically too many values to see well. So I've got the name here. So here's a unique event name, and I think cost might be the right. Maybe I'll just do cost. It doesn't matter if I have inflation adjusted or not. I don't think so. I mean, it's already too many to even read the labels, even if I try to make this bigger. Um, and I mean, you could sort this, but it's still gonna have some labels uh, conflicting. So we use a different layout called pack bars. And this is showing basically the top bars in blue is the biggest are shown basically highlighted. So that's like a regular bar chart. Some people um, call this they'll use 10 in particular and call it a top 10 bar chart. But the thing about that pack bars adds is it adds all the other bars as little grayed out bars, just to give you some context. So now we can see that, for instance, the top 10 accounted for basically half of all the other, or another way to say it is that the top 10 are almost the same area as all the gray other events. So this is a very skewed distribution, which is what the pack bar chart was designed for. Where you've got a skewed distribution, you want to get a sense of all the data, but you really want to know what the larger things are, and we can control our labeling. And another interesting way to think about this is, if I started it showing it as a bar, but we can try to make another kind of graph. Another way you might view this data, and this is more in line with the inspiration for creating it, was just was a tree map. Put that in tree map. I'll take cost and put that in. Well, I was going to put it in size, but it's under my zoom window. Okay, put it in size. So this is another way that you would try to show this high cardinality data. And even if you use a different tree map layout like Squarify, which sorts the things by size, it's still hard to compare the magnitude of the top uh, items, which are rectangles of different size, different shape. So it's much easier to compare them using the bars as much just a linear length instead of trying to compare areas. But it's the same thing. It's just showing hundreds or thousands of categories in a compact space while focusing on just a few main items.
Thank you so much, Zan. Well,
Sure.
that's all the time we have for questions. Thank you to Zan for answering so many questions and sharing so many interesting things with us about visualizing data. And thanks to all of you for asking such great questions. If you'd like to take a deeper dive into this topic, we invite you to join us for an episode of Technically Speaking on November 19th. It's called From Data to Decisions, Harnessing the Power of Visualization in Engineering and Science. We'll put that link in the chat so it's handy for you. And for more events like this, you can find a variety of topics at jump.com/statspeaking. Thanks for watching and see you soon.